Hello, everyone. Welcome back. Today, we're going to be talking about linear regression. Before we do that, though, let's do a quick review about the line of best fit. Okay, so here we have the line of the best fit, and it's asking us to draw a line of best fit for these scatter plots. So clearly, this one here, this is going to be a positive correlation, maybe like a moderate positive. This one I would also say might be a moderate positive, and this one might be like a moderate to strong negative correlation, right? So all of these have kind of a line of best fit approximately that we can draw. So linear regression is actually an analytic technique for finding this equation, right? Because here in these examples, I was kind of just guessing, right? I kind of just drew a line of best fit that I felt was approximately, good, right? However, we're going to learn how can we actually like algebraically figure out, you know, what these lines are. So let's talk about doing that. So linear regression is an analytic technique for finding the equation y equals ax plus b. Now make no mistake, this is the same as y equals mx plus b. We just use a for the slope instead of m in this lesson, but you're welcome to use m instead as well if that's more comfortable. It doesn't actually make a difference. And we want to find that exact line that's going to give the best relationship between the two variables. So for this line of best fit, we need to use the least squares method to find y equals ax plus b. So first we need to say, well, a, the slope here, would be the number of points times the sigma xy minus sigma x sigma y, and then over n sigma x squared minus sigma of x, and then that squared. And then we also have to use the fact that b is going to be the average y value minus a times the average x value. That's how we're going to find out what the b value is in this case. So we can use these equations, we can use this to find a and b. And once we know a and b, we will have the equation of a very specific line that does tell us that does best represent the data as a whole. That's going to be our scientific line of best fit as opposed to our guesstimated line of best fit. Okay, so this is actually the same example as before in the previous one. So if you haven't watched the previous lesson, make sure you do that. But I'm not going to do the same techniques again. We already found all of this stuff, so there's no point in doing these same equations again and figuring out the same stuff again. I'm going to be using what we did in the previous lesson in order to solve this one. Okay, so first things first, what is A? Well, A is equal to n, which is 6, times the summation of xy. Well, let's remind ourselves, summation of xy is what? 105.3 it was. Minus the summation of all the x values times summation of all the y values. Oh, let's put the point there, which is 48 times 12.9. 48 times 12.9. Okay, and that's going to be over n, which is 6. And then sigma of x squared. So what is the summation of all the x squared values? Well, let's see. That was 418. So this would be 418, right? Minus e to the x squared. So minus 48 squared, basically. Okay, so that's how we're going to find A. So let's continue on with that. So that means this is going to be equal to 631.8 minus 619.2 over 2,508 minus 2,304, which is equal to 12.6 over 204, which is about 0.06. So there we have it. There is our A value. Now to find our B value, B is equal to the average y minus a times the average x. So we already know that the average is what? The average is a summation of y's over n, and the average x value is going to be the summation of all the x values over the number of values, right? So that's how we know how to find the average. That's something we probably already knew even before attending this class. And that's going to be, let's see, in this case, 12.9 over 6 minus a, which actually we can plug that in. It's going to be 0.06. We already know that. Times the summation of all the x values, which is 48 over 6. So there we have it. And what's that going to be? That's going to end up being, let's see, 1.67 overall. So now we found the a value and the b value. So therefore, the line of best fit is y equals 0.06x plus 1.67. So all I did here is I just took this original equation, the basic, line format. We plugged in the a value we got, we plugged in the b value we got, and that's it. That's the answer. Awesome. All right, let's do one more example. I think we have time for one more example here still. Especially that last example, we'd already kind of pre-calculated a lot of things from the previous one, whereas this one it will take us a bit longer because we'll have to do all of it again from scratch. But basically, this one says, as an experiment, 7 individuals are asked to press a button when a light turns on. Their age in years and their response times in milliseconds are recorded below. Calculate the line of best fit. Okay. So for this one, let's review what we have to figure out for line of best fit. So we know that A is equal to n times summation of the xy values minus summation x summation y over, there we go, like that, right? We know that's our A. And then we know that our B value is equal to the average y minus a times average x. So we'll find the b value second because we already need to know the a value in order to find the b value. We'll already need the slope in order to find the y-intercept, right? Just like in a lot of regular, solving linear equations that we probably did maybe back in middle school. Awesome. Okay, so let's figure that out. Well, we obviously know n is 7, right? Because there's 7 individuals, so that part's easy. How about, let's do the next easiest things next. Let's do what is the summation of all the x values and the summation of all the y values. Okay, so let's add up all the ages together. So 24 plus 27 plus 32 plus 38 plus 42 plus 55 plus 63 is equal to 281. So 281 for this one. Awesome. Now, what about the average, or not the average time? Sorry, we'll find that later. What about the addition of all the times? Okay, so the addition of all the times is going to be 250 plus 275 plus 320 plus 410 plus 425 plus 760 plus 890. So that's 3,330. Awesome. Okay, so what do we have to find next? We need to find next, the xy values. And then, of course, at the end of that, we need to find out what is the summation, what is the addition of all of those values. So let's do that. Let's make another kind of column here, and we're going to multiply out all of these things, which is, I get it, it's very tedious. It's not very fun work, but it's also not very challenging work, which is the positive in this. Okay, so 24 times 250 is 6,000. 27 times 275 is 7,425. 32 times 320 is 10,240. 38 times 410 is 15,580. And then 42 times 425 is 17,850. 55 times 760 is 41,800. And then 63 times 890 is 56,070. Okay, so now we've got to add up all those values. That's going to add up to at least 100,000. That's for sure. It's going to be a big number, but let's add them up. All right, 50, or sorry, I think I made a slight error here. I wrote 57, but it should have been 56. That's what it says on my calculator, 56, not 57. Okay, so let's add all those up. So 6,000 plus 7,425 plus 10,240 plus 15,580 plus 17,850 plus 41,800 plus 56,070. All right, so that gives us 154,965. So there we go. Very good. All right, and what's the last thing we need to find? We need to find at the x squared values. For this one, notice that actually we don't have to find y squared. We would have to do that if we were finding, if they also asked for the correlation coefficient, which is what we solved for last time. But this time they only want us to calculate the line of best fit. And so there is no sense in figuring out the y squared value because that isn't relevant here. Okay, so let's square all these values. So what's 24 squared and then 27 squared and so on? We got to square all of them. Okay, so 24 squared is 576. 27 squared is 729. 32 squared is 1024. 38 squared is 1444. 42 squared is 1764. 55 squared is 3025. 63 squared is 3,969. Awesome. All right, so let's add all those up and divide by 7. Actually, no, let's just add them all up. Sorry, not divide by 7. Okay. So if we add all those up, we're going to get 12,531. Awesome. So now we have all the information we could possibly need in order to solve all this stuff. Well, pretty much, there's nothing else major we need. So A would be equal to 7 times e to the xy, which we already calculated. We said that was 154,965 minus e to the x, e to the y. So minus 281,3330, like that, over, let's see, n, which is 7, e to the x squared. The summation of x squared is going to be, I should be saying sigma x squared, 12,531. Let's see, minus sigma x squared, which is 281 squared. Okay. And that is going to end up being 1,084,755 minus 935,730 over 87,717 minus 78,961 equal to 149,25 and equal to 8,756. So that's going to be equal to 17.02. All right, awesome. So we figured out A. Now we need to figure out B. So B is equal to this. And we know that the average y value is going to be the sum of all y values over n, and likewise the sum of x values over n is going to be the average n, or the average y, or the average x value, sorry. And then A, we already figured out, was 17.02. Awesome. Okay, so this is going to be 3330 over 7 minus 17.02, 281 over 7, like that. which is equal to negative 207.47. Good. All right, so therefore the line of best fit is y equals 17.02x minus, oh, not plus, minus 207.47. Awesome. So there we have it. All right. Well, you know what? That concludes not only this lesson, but that actually concludes this unit. Next unit, we're going to talk about counting principles and combinatorics, which I think is an awesome topic. I will say it's a lot more fun, a lot less tedious than this topic and the previous lesson topic, which, to be honest, are not my favorite because a lot of little tedious calculations. One positive I can say about linear regression and also about the correlation coefficient is that in practice, most of the time, outside of like taking it in a school course, this would be something that professionals would use either spreadsheets for or a computer program for. Like professionals don't spend their time all day doing all this number crunching; they just don't. So that is the one positive spin I'll put on this is that other than when you're taking courses, you're not likely to actually be asked to do this by hand. Probably, when we have computers to do it for us at this point. But it is good to know how to do it by hand, just so that we have a good understanding of what exactly it is we're calculating, what exactly it is that the computer spits out on us when they tell us what the R value is, or when they tell us, here's our line of best fit. Now we know how did they get that, which is important. But yeah, that is it for today. I will see everybody next day for our unit 2. Bye, everyone.